Maxima and minima. Question. Show that the volume of largest cone that can be inscribed in a sphere of radius small r is 8 by 27 of volume of sphere. So here sphere is given whose radius is small r, and this is cone whose radius is capital R, and height of cone is AD. So AD is H. OA equal to small r, then OD will be equal to H minus R. And here in this triangle OCD, we can apply Pythagoras theorem. So from where we can get R square equal to small r square plus, sorry, not plus, minus H minus R whole square. So if we open the bracket, it will become R square minus H square minus R square plus 2RH, which gives 2RH minus H square. Now we have to maximize the volume of cone. So we write formula for volume of cone 1 by 3 pi r square h. We put the value of r square. So 1 by 3 pi into r square, that is 2rh minus h square times h. We multiply inside 1 by 3 pi, then this will become 2rh square minus h cube. For maximum or minimum, we have to differentiate it. So, and then we have to equate it to 0. So dv upon dh. Here r is constant because it is given that the radius of sphere is fixed. So dv upon dh, 1 by 3 pi, this will become 2r times 2h minus this will become 3h square. So let's get second derivative also here. So it would be helpful. So d2b by dh2 equal to, this will become 4r and 1 upon, sorry, here pi divided by 3 outside, 4r because s will be 1 and this will become minus 6h. So we have got second derivative. Now in order to have maximum or minimum value, we have to equate dv upon dh to 0. So we can put dv upon dh to 0, and then if we put dv upon dh equal to 0, that is 1 upon 3 pi times 4 rh minus 3h square equal to 0. So from here we get 4rh minus 3h square equal to 0. So h common, 4r minus 3h equal to 0, from where we can get h equal to 0 or h equal to 4r by 3. H equal to 0 can't be taken. So h equal to 4r by 3. Now we put this value in expression of second derivative here, d2b by dh2. So here we are going to put the value of h as 4r by 3. So when we put this value d2b by dh2, so what it becomes, pi by 3, and inside bracket it will become 4r minus 6 times 4r by 3, which will be minus 4 pi r divided by 3, which is less than 0. Hence function is maximum. Now at this value of h, let's find out the volume of cone, and then we will compare it with volume of sphere. So volume of cone 1 by 3 pi r square, and r square we got as 2hr minus h square times h, that is pi by 3 times 2h square r minus h cube. Now we put here h equal to 4r by 3. So it will become pi by 3 times 2r into 16r square upon 9 minus 64r cube upon 27, which will be equal to 32 pi r cube divided by 81. We know that volume of sphere is 4 by 3 pi r cube. So let's separate 4 by 3 pi r cube from here. So we can write this is V of cone. Keep in mind. So that is equal to, so if we separate out 8 by 27 from here, then V will be left with 4 by 3 pi r cube. So we can say that V cone equal to 8 by 27 V sphere. And if we see the question bar show that the volume of largest cone that can be inscribed in a sphere of radius small r is 8 by 27 of volume of sphere, and our result is V cone equal to 8 by 27 of volume of sphere. So our purpose is served. Thank you for watching.